32, which is a binary problem. Say evaluate 1011 square in base 2 minus 101 square in base 2. So this is what we are going to do. 1011 square minus 101 square. So now what we are going to do is converting this number in base 2. We are going to convert it to normal base 10, which is the normal 1, 2, 3, 4 we normally use. So now we are going to convert this and also raise it to power 2, not forgetting the power present. So this, we know our normal binary conversion, 1, 0, 1, 2, 3. So this is 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. 3, 2, 1, 0. Okay, we're on point. Not forgetting the square present here. So this is 1 times 2 raised to power 3, which is 8, plus 0 times this. The 0 automatically cancels out. This is 0. 1 times 2 is 2, plus 2 raised to power 0 is 1, always 1, times 1, which is 1. Not forgetting the square, most important. So this is 8 plus 2 plus 1, which is 11. So this is 11 square. So if you multiply 11 by 11, it's 121. So we go 121. So we are going to do the same thing that we did for 101. So this is 1 times 2. 0, 1, 2. So this is 2 plus. This is 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0. 2 raised to power 2 is 4 plus 0 plus 1 is equals to 5. So now we should not forget our square, most importantly. There is square. Translate to 25. So now that we have gotten this, we are going to subtract this from this. So this is 121 minus 25. This is 96. So now we are going to convert this 96 to base 2. Yet, we are going to convert this 96 to base 2. So now we are going to divide through using our normal base 2 conversion. 2, 96. 2 going to 96 is 48. Remainder 0. 48, 2 going to 48 is 24. Remainder 0. 2 going to 24 is 12. Remainder 0. 2 going to 12 is 6. Remainder 0. 3 remainder 0. So 2 going into them. 2 going to 3 is 1, remainder 1. 2 going to 1 is 0, remainder 1. So we are going to take our reading up. We are going to take our reading up, which translates to 1, 1, 0, 0, 0, 0, 0. So this is in base 2. So this is our final answer. So now we are going to take a look at question 23. See, if x is all perfect squares less than 40, y is equals to all odd numbers from 1 to 15. So now that we are going to attempt this question. So now we are going to write out all the values for x. All the values for x are perfect squares. Perfect squares less than 40. So all the numbers that when you multiply them, they equal themselves from 1 to 40. So 1 is a perfect square. We are going to write it out. 4 is a perfect square. 9 is a perfect square. 16 is a perfect square. 25 is a perfect square. What again? If we say 36 is a perfect square. We cannot say 49 because 49 is less than 40. So we are now looking at y values. Y values, all odd numbers from 1 to 15. So let's write out all the odd number, which is 1, 3, 5, 7, 9, 13. So yeah, that is it. So now we are asked to find x intersection y, which is the number that is common between this set and also common between this set. So if we look at these two groups of sets, what are the common terms or common strings that we think are common between the two? So which is 1 and 9. So this is x intersection y, is it? So now we are going to be looking at question 34. It says calculate the length of an arc of a circle diameter 14 centimeter, which subtends an angle of 90 degrees at the center of the circle. So now we are going to be writing out the formula for length of an arc. For the formula for length of an arc is, let's say length of an arc is theta over 360 times. From our question, they said the diameter is 14 centimeter. And we can recall that diameter is equals to radius over, no, radius is equal to diameter over 2. So and from the question, our diameter is 14. So our diameter is 14 over 2, which gives us 7. So now we are going to impute it into this equation. And they said the angle that in which the arc subtends is 90 degrees. So it's 90 over 360 times 2 pi r, which is 7. So this is going to give us 1 over 4 times 2 pi 7. 1, this cancels 1 over 2. So this is 7 pi over 2. Yes, we're on track. So that is the answer for question 34. We are going to be looking at question 35. It says if the lines 3y equals to 4x minus 1 and qy is equals to x plus 3 are parallel to each other, find the value of q. Question 35. Three y is equals to 4x minus 1. Q y is equals to x plus 3. So now we are going to say for parallel lines, the gradient, the slope is equal, this determinant is equal between the two lines. So the slope of the first one is equal to the slope of the second one. So using the relationship y equals to mx plus 1, this is the gradient. So the attachment m is the gradient. So looking at relating it to this, we can figure out that 4 is the gradient for this. And this one, y, is separately on its own. So there is no attachment to this. So any number that we have here, we are going to divide it. So we just want y to be standing on its own. So we want to find the gradient for this first one. So that is what we are going to be doing. So now, therefore, y is equals to 4x minus 1. We are dividing by the 3 here. So this over 3 over 3. So now y is equals to 4 over 3x minus 1 over 3. So this is the gradient. 4 over 3 is equals to m. 4 over 3 is equals to m. So now, for parallel lines, m1 is equals to m2. So now, looking at this equation, if we divide, we want y to be separately on its own. So we are going to divide through by q. So this is y is equals to xq plus 3q. So this is going to be y is equals to, because our focus is on the q, So now, if we impute the this thing, if we impute, we know that our gradient is this. So if we equate it to this, we know this is our gradient. M2 is equals to 1 over Q. And we know that M1 is equals to M2. So this is 4 over 3 is equals to 1 over Q. From the question, they say we should find Q. So making Q the subject of the formula, this is 4Q is equals to 3. So dividing by Q, dividing by 4, this is going to be Q is equals to 3 over 4. So that is the answer. So now we are going to be looking at question 36.
SmartSpark Academy is proud and excited to officially present our past question sessions for all courses. This initiative is designed to help students gain a deeper understanding of key concepts, master frequently asked exam questions, and build strong confidence ahead of internal and external examinations. Our sessions will involve step-by-step explanations, smart problem-solving techniques, and practical tips that make learning easier and more effective. Whether you are preparing for school exams, WAEC, NECO, JAMB, or other academic assessments, SmartSpark Academy is here to support your journey to success. Stay tuned so you don't miss out on these powerful learning sessions. Subscribe to our YouTube channel to access past questions, video tutorials, and detailed explanations across all courses. Tell your friends and classmates. Learning is more impactful when done together. Join our WhatsApp group for interactive brainstorming sessions, discussions, and peer-to-peer learning in a supportive academic environment. Don't forget to follow us on Facebook, SmartSpark Academy, where we share updates, learning tips, announcements, and free academic resources. At SmartSpark Academy, our goal is to make learning simple, engaging, and result-oriented. Stay connected, stay consistent, and let's work together to achieve academic excellence. SmartSpark Academy, unlocking knowledge one spark at a time.
Question 36 is a 3x3 matrix whereby we are asked to find the determinant. So this date is 2, 4, 8, 0, 6, 9, 5, 3, 1. So now this determinant is quite different from the matrix we are used to. So we are going to break it down into 2x2 matrix and assemble it back. So we are going to take this first parameter, this one. Any number that falls between the row, we are not going to take it. The rows and the column, we are not going to take it. This is going to be 2 brackets 6, 9, 3, 1. So now we are going to, this second row is going to be a minus. This minus 0. Going to be any number that falls within the rows and the columns, we are not taking it. 4, 8, 3, 1. For the 5, we are going to do the same thing, plus 5. It's going to be 4, 6, 8, 9. So now we are going to do the same thing that we usually do for a 2x2 matrix. So this is going to be multiply this by this and minus it from the difference between this and this. So now this is going to be 2. 6 times 1 is 6 minus 3 times 9, which is 27, minus 0. We know that 0 multiplies by any number is going to be 0. So we can decide to omit this for time's sake. So this is plus 5. 4 times 9 is 36 minus 48. So now we are going to do our normal computation. 6 minus 27 is 21. Is 2 minus 21 minus 0 plus 5. 36 minus 12 is minus 12. So now we are going to multiply this minus 42 minus 60. So now summing this up, we are going to get minus 112. So that is our answer. So now we are going to be looking at question 37, whereby we are asked to find the inverse of a 2x2 matrix. So this is the matrix. P is equals to 2, 1, minus 3, and 1. So now, firstly, we are going to find the, the determinant, which is A, the determinant of the matrix, D is equals to AD minus BC. So we know from looking at this A, B, C, and D. So this is 2 times 1 minus 3 times 1. This is 2 minus 3. So minus is plus, which gives us 2 plus 3, which is 5. So now we are going to find the transpose of this matrix, whereby this matrix we are going to inverse it using the earlier talked about formula we used. So the A's, we are going to inverse them, and this other part we are going to inverse them, doing a sign change for both this side and this side. So this is going to be 1, 3, minus 1, and 2. So now we are going to multiply this transposed matrix by the inverse, which is 1 over determinant. We are going to multiply to get the inverse, P inverse. So now the P inverse is equal to 1 over 5, 1 minus 1, 3, and 2. So now we are going to multiply each individual unit in the cell by each other. This is 1 over 5 minus 1 over 5, 3 over 5, and 2 over 5. So that is the answer for question 37. So now we are going to be looking at question 39. So if the two smaller sides of a right angle triangle are 4 cm and 5 cm, find this area. So now this is a triangle we are looking at. And they told us the hypotenuse is the largest side. And these other sides are the smaller sides. So that is what the information that we need to solve this problem. So now this is 4 centimeter and 5. So we should find the area. The area of the right angle triangle is half base times height. So now it's going to be area A is going to be half base times height, which translates to 1 over 2 times 4 times 5. 2 going to this 2, which translates to 10 centimeters square, which is the area of the right angle triangle. So now we are going to be looking at question 40 next. Question 40 says, a cylindrical pipe 50 meters long with a radius 7 meters has one end open. What is the total surface area of the pipe? I'm just going to use the formula of an open-ended cylindrical pipe to solve this. The formula is pi r root square plus 2 pi r h is the area of a closed cylindrical pipe. Our radius is 7 meters. So this pi, I'm going to put our radius as square plus 2 pi r is what? 7. And our height is 50. So now this pi square 49. 7 square is 49 plus 2 times 7, which is 14 pi multiplied by 50. So now this This is 49 pi plus 50 times 14 is going to be 700 pi. So now, summing both of them up, 700 pi plus 49 pi is 749 pi. Thanks for watching to the end. Make sure you like and subscribe and drop a comment. Any question that you are unable to follow through or understand, just tag it in the comment section and we'll attend to you. Thank you for watching.